challenge to the scientist community, and this time they have taken it up in a way that it should and it will succeed. ISRO's Chandrayaan-3 is scheduled for launch from the Satish Dhawan Space Center in Sriharikota on 14th of July. Now, the mission's primary focus will be the moon's South Pole region, known for its intriguing potential of water presence within perpetually shadowed areas of the moon, also referred to as the dark side of the moon. These shadowed craters, acting as cold traps, hold the promise of revealing clues about the early stages of the solar system. Chandrayaan-3 will replicate the objectives of its predecessor, Chandrayaan-2, with a primary emphasis on demonstrating a complete end-to-end capability for safe landing and rover exploration on the lunar surface. The decision to embark on another mission was prompted by the Vikram lander's unsuccessful soft landing during the previous endeavor, necessitating additional testing of the landing capabilities crucial for the lunar polar exploration mission. ISRO Chairman S. Somnath has highlighted the modifications made to Chandrayaan-3, incorporating a stronger and more durable engineering approach compared to its predecessor. The new version boasts improved instrumentation and sturdier impact legs to mitigate any potential issues. Additionally, a backup system has been implemented to ensure operational reliability in the event of any failure.
Okay, Chandrayaan-3 launch is happening tomorrow at 2:35 p.m. Our very strong rocket, big rocket LVM-3 in its fourth continuation flight mission M4 is going to launch Chandrayaan-3. So Chandrayaan-3 will start its journey after the launch tomorrow. So it will reach around Earth, then it will travel towards Moon slowly over the next 1 month. Then we are hoping that everything is all right. Then it will reach and land on the moon on August 23rd onwards, any day. So I need the blessing of Gangamma Devi. So I came here for praying and seeking blessings for the success of this mission. So I thank all of you. You also wish and pray for this mission. Countdown will start tomorrow at 1 o'clock. Today at 1 o'clock. 105, sir. 100.
And there you saw the chief of ISRO with his team. The team of the scientists today had visited Tirupati Venkatachalapati temple ahead of Chandrayaan-3's launch. Scientists visited the Tirupati temple with miniature models of Chandrayaan-3 to pray for its successful launch.
మేడం వెళ్ళాలి అందరూ ఒకటిగా వచ్చేసేయండి.
Definitely divine blessings also in order for this mega launch on July 14th, which is Friday at around 2:35 p.m. Well, joining us on the broadcast are two names which need no introduction, but yes, Dr. G. Madhavan Nair, former chief of ISRO, and Ravi Gupta, former scientist DRDO. There, gentlemen, please accept our heartfelt thanks and gratitude for taking time out on this auspicious occasion, I would say, no less than that. Dr. Nair, to begin with you first, obviously, first of all, congratulations to you and your team, the whole scientist fraternity also, for taking such a big leap once again, venturing into the unknown as they have always been doing. Dr. Nair, your initial thoughts on the big day tomorrow and your hopes and aspirations, what are they saying?
Well, it's going to be a very important day as far as the Indian space program is concerned. And the mission, as you have explained, is going to be a very complex one. The GSLV Mark III rocket will carry the composite spacecraft around the Earth, and then later it will be slowly raised to the orbital heights, reaching up to the moon. From there, it will be captured into the lunar orbit. And after stabilizing and verifying all the performance, it is going to land on the surface of the moon. Again, after landing, the rover will come out and it has to do the exploration. As you can see, there's a series of activities which have to take place successfully. ISRO is known for its quality and reliability. Last time, the target was missed very narrowly, just about 2 kilometers above the lunar surface. Something went wrong, and the entire module crashed onto the moon. This time, as Dr. Somanathan has explained, they have investigated various possible reasons for such an anomaly and performance deviation, and all those have been set right. And again, a large number of simulations have been carried out. That gives the confidence that we will be able to achieve the target without any glitch. But as you know, this is an extremely complex operation, especially entering the moon orbit, and from there descending slowly to the lunar surface is a big challenge. You know, on the Earth, once we break the orbit, we enter the atmosphere, and there is the atmospheric drag which helps in reducing the velocity, and finally, with a set of parachutes, it slow down to touchdown speeds acceptable level. Whereas in the moon, this kind of luxury is not available. There is no atmosphere. So entire operation has to be done by a set of rocket engines, the control system on board, the sensors like the stereoscopic cameras, laser ranging system, and so on. All these instruments have to work perfectly, and also the entire territory is unknown. On the Earth, most of the regions where we attempt to land, etc., is known, and one can definitely find a trajectory. But here we are going to an unknown territory, and with a totally blind type of landing, and we believe the onboard instruments will help us in steering it properly and reducing the speed to the touchdown velocity which is needed and ensure a soft landing. After landing there, again, we have to watch for the temperature conditions. As you have said, that it's the dark side of the moon, much of radiation from the sun, etc. And we have to see that all the instruments are kept warm enough to perform its duty. And once the rover comes out, again, we don't know what is the terrain, what are the type of obstacles around. So those have to be mapped by the camera and then work out a path through which the rover will move around and do the experiments on the surface of the moon. So this is a really exciting event, but at the same time, full of challenges, and one can have any of course, thorough testing is done, but still, if there is an unknown glitch props up, we may have a problem. But I hope it will not happen. And Chairman ISRO has prayed at the Tirupati temple, and I'm sure there's a practice all these years. And certainly the divine grace will be there to have this mission successful.
Right. Prophetic words there, Dr. Nair. Thank you so much. Stay with us. Ravi Gupta is also there. Thank you so much, Mr. Gupta, for taking time out. Your initial thoughts, beginning with also the objectives of Chandrayaan-3.
See, Chandrayaan-3 has several objectives. The primary two objectives are enhancement in the knowledge level, knowledge related to the process of reaching the moon, as well as knowledge about the moon surface, the kind of radiation that is coming on the moon, as well as this time there is one more experiment looking back towards the Earth.
Right.
The aim is that we we know that the Earth is a habitable planet. We are living after all on Earth. So what kind of signatures, life signatures are there on Moon? When the Earth is visualized from a distance, say from Moon, what kind of signatures it is seen? Now, why it is needed? Because if we are looking at life elsewhere in the space, then we have to look for certain signals. So those signatures which we generate, these will be helpful in search for life elsewhere in the universe. So that, as I said, this is one primary objective is the knowledge generation. Then the
Right.
second primary objective is the technology demonstration for the technologies needed to go to the moon and land on the moon, do a soft landing, and carry out the required tasks. So these two are the primary objectives of this mission, and I am sure that these will be achieved. Last time also when we went there, as Dr. Madhavan sir has very beautifully explained, we had, I call it a great success. I don't, there is no question of failure
Yes,
because
yes, yes, indeed,
whatever,
indeed, it's a success, yeah.
yeah, whatever happened, first of all, the orbiter is there instead of 1 year, it will be available for almost 6 to 7 years. It's a grand success. But more than that, whatever small glitch happened, in fact, I won't call it a glitch, it was some kind of a design in the software where certain parameters have been catered for. Now, no software can take care of 100% parameters. Now, when the parameters went beyond those limits set in the software, then the problem occurred which was not envisaged earlier. As a result, what has happened? As I said, one of the primary objectives of Chandrayaan-2 as well as Chandrayaan-3 or any other mission is knowledge generation. Now, whatever happened during that Chandrayaan-2, analysis of that, the failure analysis, has given us immense information about what can go wrong. So, had it been, we have had successfully landed, as compared to that, now today we are much more enlightened, much more knowledgeable about the entire process, and I'm sure that this time it is going to be a grand success.
Right. Definitely, our best wishes are there. Dr. Nair, also talking about in terms of landing and preventing or making it doubly sure, ensuring that all goes well. Any lessons that have been taken from Chandrayaan-2 and how they have built up on the previous experiences?
Certainly, as was pointed out earlier, the mission up to about 2 kilometers above the surface of the moon was perfect. It planned as per the planned trajectory it went. But then the entire platform has to be kept floating with the thrust from the rockets, and this has to be very precisely controlled. There can be many reasons why it can fail. Suppose any of the thruster is giving a lower thrust than what is expected, and suppose there is a misalignment in the thrust value, or if there is a stereoscope camera images, if there are problems, and in algorithm used for controlling and velocity as well as attitude together, there could be a problem. So if any of these elements fail, we have this end result will come. The data which was available in the last few seconds were very meager to clearly pinpoint such a reason. But what ISRO has taken the approach is to look at all aspects, irrespective of whether it was successful or failure, and then revisit the design adequacy, the limits of operation, and also in case any of the subsystem malfunctions, what kind of redundancies can be provided, how salvage operation can be done, etc. All this has to be discussed over the last few years. And the result is that a lot of strengthening of the thrusters and the landing gear has been done. And again, the algorithm has been revisited, redesigned, and the safeguards have been built in. And again, afterwards, a large number of simulation for nominal flight as well as off-nominal flight has been done. And that gives us reasonable confidence that we should be able to achieve this time without any major issue and land successfully on the surface of the moon.
Ravi Gupta, sir, I'm sure all hands on deck situation is there. In your opinion, how is ISRO ensuring this time around the success of the soft landing and also on the lunar surface for Chandrayaan-3 this time around?
Yeah, as I said, the last time, whatever had happened, it has been very thoroughly analyzed. And the last mission also was, you can say, even the landing would have been successful had such an event not taken place and such a situation had not arisen, it would have landed. Now, this time, what they have done is that what the ISRO, recently the ISRO chairman had very beautifully explained all these aspects. That earlier mission was designed as a success mission, designed for success. That we are assuming that these things, parameters, this event will take place.
Yeah.
There is a big difference. Now they have tried to incorporate as many ways the system can fail, and then what decision the software is supposed to take in case of a parameter going beyond the limits. So not only that, the limits have also been enhanced. The last time the Chandrayaan-2 was supposed to land on a very small patch of 500 meter by 500 meter. 500 meter by 500 meter may look a very big patch, but from when you are going to moon, a place like moon, and going to land for the first time, I think it's a very, very kind of a pinpoint accuracy. Now, what happened that since the distance was still more from the target, the software, they couldn't understand what is supposed to be done now. It has started accelerating instead of decelerating, as told by the chairman. So it resulted in a problem. Now this time what they have done is, first of all, the area has been enhanced, 4 kilometer by 2 kilometer. It's a much larger area. And at the same time, even whatever else can go out of the parameters. Now what exact decision has to be taken by software? These have been incorporated in the present software. That is because hardware last time also it was sufficient, but not taking chances, they have even further ruggedized the hardware. Like for example, the last time the lander was supposed to withstand a landing of 2 meters per second velocity. This time it has been enhanced to 3 meters. It means even if the speed is slightly higher, it will be able to land successfully without any damage. So these are,
Yes, please complete your thoughts, sir.
So with these, I'm very much confident, and the ISRO scientists are very much confident that this time we will be able to land and become the 4th nation in the world to have their own capability to land man-made object onto the surface of moon and carry out the desired experiments.
Right. Dr. Nair, Mr. Gupta, both of you have been part of so many explorations and launches. For the layman, obviously, for those who are watching the liftoff on the TV, they don't know, what happens beyond the scenes. Dr. Nair, from your point of view, from your learned opinion, the words, terminologies like lander and rover, they, came into much usage during Chandrayaan-2. I mean, that was the time when Vikram, the name, how it was christened, all those stories came up. Please share with us what crucial role these landers play, what is a rover, and why it is important to for them to be placed at exact location where you intend them to be.
Well, our first mission to moon was a remote sensing mission. Actually, we had the cameras, stereoscopic images, laser ranging system, etc. on board. They took the pictures from about 200 kilometers altitude, and most of the surface have been mapped. And there is some idea about what kind of deposits are there, minerals especially. And the most unique finding was the presence of water in the polar region, and also traces of water on the surface itself in the hydrate form. So this is actually the scientific finding. And there is nothing like in situ verification of these values. So the lander and rover is designed to accomplish and give a complementary information on the data which has been collected by the earlier mission, Chandrayaan-1 as well as the Chandrayaan-2 orbiter. So here you carry a set of instruments and they have to reach the lunar surface, collect samples from there, analyze, and give the results back to Earth. So this is the kind of mission which is required. So the spacecraft is moving around the moon along with the orbiter, and it will be stabilized, and as maybe the health parameters all be monitored within a month's time. Then the thrusters will be fired so that its velocity is reduced slightly. So it will start descending towards the moon. As it is descending from about 1.7 kilometer per second, the speed has to be brought down to as low as about 2 meter per second. That is acceptable velocity for a touchdown. Anything beyond that, the shock levels will be high. It will damage almost all the instruments. To ensure this, these thrusters are fired again the reverse mode, and the onboard computers will keep monitoring the velocity, position, and orientation, and give the corrective commands. There is a control function involved in stabilizing the attitude. There is a guidance function involved in steering it to the right spot, and the navigation to precisely locate it. All these are done with autonomous instruments on board and without practically any intervention from the ground. So it is all programmed to carry out this thing, and decision making is done by the onboard computer. So you can imagine that there is no feasibility of intervening at any stage of this landing. Only we can initiate the sequence, and afterwards we have to make sure that every instrument works properly. So ultimately, the entire spacecraft, the lander, will float like the objects which you have seen in the science movie, like the flying saucer, and it will float around the moon, and slowly it will be placed on the surface of the moon. If we succeed in that operation, that is the first major achievement. Then, of course, the rover has got a set of wheels and drive mechanism, and again, it has got cameras to take the image and do the steering program. So it will look for the obstacles and then try to steer away from that, and it has to precisely move around inch by inch, and then finally collect samples at different locations. Where we land and how far it can go, etc., are going to be depend on the surface features where we are going to exactly hit. I hope that you will not hit a crater or some deep hole so that it gets a problem. But any other place certainly will be able to have a movement maybe over 200 meters, and within that range, not only have the images taken, stereoscopic images, multiple images, and also samples will be collected, and also thermal profile will be measured, and so on. So this is the kind of scenario which you're going to have. And it's a totally an autonomous landing system, which we are going to try in a totally uncharted territory. So to that extent, the risks are very high, and we have stretched our imagination to maximum. But still, there could be some problem if it is beyond our control. But we have to keep our fingers crossed. Every instant from liftoff for the next 1 month is going to be very, very crucial. And every movement of the spacecraft will be monitored by the ground controllers. And we hope that everything will function as designed to achieve the final goal.
Right. Fascinating facets and aspects of space exploration. Chandrayaan-3 journey to the moon, while listening to it, it gives us, it draws a picture in our mind, and I'm sure the same happens with our viewers also, with the kind of research and technology, R&D also goes into it. Mr. Gupta, obviously talking about, the role and the objectives that need to be fulfilled, or lander and rover will help us to achieve there. The aspect of presence of water and the early beginning of the solar system, that is one key area which also is coming up as one of the crucial takeaways from this mission. Your thoughts on that?
Exactly. See, of course, for that matter, Moon is supposed to be a repository of very valuable resources. And in my opinion, among the most valuable resources among all them is water. Not just because tomorrow if we want to set up our station at permanent station at Moon and a manned station at Moon, the water is going to be needed for human consumption and other processes. More than that, the the water as such is a new fuel for propulsion. If we have to launch interplanetary missions, we need fuels. And if you are carrying entire fuel from the Earth, these are going to be very, very expensive. Now, scientists have discovered at least two distinct ways of using water as propellant. One is, of course, the conventional method, where you use the electricity. And of course, electricity is, as such is available because on the moon you have unrestricted supply of solar energy for pretty long duration. So you can generate, you can have solar power plant over there, or you can set up a nuclear power plant and have plenty of energy. But as such, you cannot use the electricity for propulsion in the space.
Okay.
The only one thing works in the space, and that is the Newton's third law. If I have to move forward, I have to push something backward. And there the role of water comes into picture. So one way is that you use electricity, decompose water into hydrogen and oxygen, and then combine the two as a propellant, as we do in other cryogenic engines also. But there is another, even more innovative way of using water as propellant, and that is through microwave electric propulsion. Water has a very high interaction with microwaves. Microwaves as such can be generated from the electricity available. So now what we do is the microwave lead to spontaneous and intense heating of water to the extent that water gets transformed into plasma. Plasma is, as we know, is a state where the atoms are, even the electrons are stripped of atoms. So it is a kind of all ionized matter. And now, since it is ionized, it can be controlled by means of magnets, strong electromagnets, and speed it up. So you can accelerate this plasma and throw it backwards with a very high velocity. And of course, the velocity can be increased to very high limits because it is all, there is no pressure involved, there is no strong heating involved except the electromagnetic forces and microwave heating, which can be contained in small spaces without allowing it to touch the given containers. So the whole engine becomes very compact, the whole propulsion system becomes very compact, and you can achieve much higher velocities as compared to the conventional kind of propulsion. So this is something which on which ISRO is working. Some of the private companies in India, the startups, they have started working, and I am sure that tomorrow the discovery of water will be a very useful, very vital, of great importance for further journeys into the space, deep space.
Right. Indeed, Mr. Gupta. Dr. Nair, obviously, all efforts are in the right direction. It's all systems go. When the primary objectives are achieved, since ISRO also focuses on the dissemination of the information. So how does this data and the finding, say from Chandrayaan-3, would be shared within the scientific community and subsequently with the public? What is the mechanism there, and what is the procedure?
I'm not up to date on the topic, but still what we have been practicing has been, there will be a principal investigator from the ISRO side who will be custodian of all the data which is being collected. And then after preliminary scrutiny and other things, and it will be made available to the other institutions, whether it is R&D organization or the universities, and even the students who are doing research, they can access this data with a cool off time, maybe of the order of 6 months or so. Then afterwards, it is available in the public domain, and any scientist can try to make use of that data which is collected and have their own assessment about what is happening there. But ISRO's objective will be first to the technology demonstration and prove the technical skill. The secondly, the data which is collected to look for any exotic things. For example, the Chandrayaan-1 mission, we never expected that we will be able to really make the path-breaking finding of water, and that too in huge quantities around the pole.
Wow, lovely.
Now, the scientific community has gone over it and analyzed and things like that. And now they have confirmed that while the moon is formed about 4 million years back, water would have been carried from here. And that, since in the polar region, in the dark region, there is no sunlight falling on that, in the sub-zero temperatures. So in the ice form, it is still there. Whereas whatever water was in the equatorial region, etc., it has vaporized and there is nothing left. But the hydroxyl modules, with molecules which are created by solar radiation, is there. So, if you want to extract water from the poles, it is relatively easy. But at the same time, if you want to extract water from the equatorial region, it's going to be very complex. From the compounds which are there, the whatever traces of water is there, that has to be chemically extracted. Similarly, the helium-3 deposits which is found by the Chandrayaan-1 is very unique. And this mission will definitely confirm whether that observation by the remote sensing cameras is correct or not. And of course, the ISRO has generated a huge volume of data on mapping the surface with various type of possibility of minerals and deposits which is there and so on. So this will, it will calibrate, this particular mission will give a calibration to the data which is available. So ISRO is normally a very open organization. After the initial investigation period, which is the responsibility of the principal investigator, the data is made available in public domain for the scientific community nationally and internationally.
Right. Obviously, and following which, generations and generations benefit from it, and obviously the world also watches as India takes another giant step. Mr. Gupta, we discussed the all-important lander and the rover. Now, talking in terms of this Bahubali rocket, this morning when we were flipping through the newspapers, the term Bahubali obviously makes our heart swell with pride. So share with us some information regarding this upgraded Bahubali rocket, the power, and now it is being known as Launch Vehicle Mark III, LM3. Your thoughts?
Yeah, see, this is till date, this is the most powerful rocket system. I would say not just one single rocket, it's a rocket system consisting of the boost, it's well-proven boosters and the main motor and the next stage and then the cryogenic stage, and all these things put together. So far, whatever ISRO has designed, this is the most powerful rocket engine. And beyond that, I mean, if we go into the technical details about the numbers and figures, it will be very
right. No, obviously,
But what for common person what need to understand is that from what we started as sounding rockets long ago in 60s to this present status of having LV-M3, this is a giant leap in the ISRO's capabilities, and this particular rocket is very well capable of taking not only the Chandrayaan and even higher payloads, even the Gaganyaan is supposed to be planned to be used. I mean, this is to be used for the Gaganyaan as well. According to my information. So this is the most powerful one and very, very well proven. It has this is the 6th flight, out of which we are calling it M4 because it is the 4th operational flight. The first two were the experimental flights, and then it is a well-proven rocket, very, very reliable and very powerful.
Right. Dr. Nair, I would like you to, build upon what Mr. Gupta has also mentioned, talking about the initial challenges associated with launching such a massive rocket and satellite into space. What key areas are kept in mind?
Well, as you know, Dr. Sarabhai has set the goal that India should have the self-reliant capability for accessing space.
Right.
And not only that, have the spacecrafts and systems which is built and benefit the society at large. We started in a modest way by launching a 40-kilogram satellite in 1970.
Right, sir.
70s being developed. And 1980 was the first launch. Dr. Abdul Kalam was the director of the time. That had about 40-kilogram capability. Then we had to increase the payload capability. We went through what is called the augmented satellite launch vehicle system, where it was raised to about 150 kilograms. But most of the propulsive modules developed for SLV3 was used in this. Subsequently, the scientific community came out with requirements of launching about 1,000 kilogram satellite class, and that is where the PSLV emerged. Like the Bahubali, what we are talking about, PSLV is a workhorse launcher for ISRO. Barring the first failure, they didn't have to look back. Of course, in between there was another failure also. Nearly 60 launches have been successful. The success rate is better than most of the even in the developed countries. So that way it has become a reliable operational launch system. It can carry medium range payloads, about 1,500 kilograms into low Earth orbit, or about 1,000 kilograms into the polar sun synchronous orbit or the geostationary orbits. Now, then again, we were depending on the launchers from Europe and Russia for launching our heavy communication satellites. So that gap filling was taken up by the GSLV. Initially, the GSLV rocket, it's called Mark II, was developed with sort of a Russian engine, which was bought on a turnkey basis, and we used it for the initial trials. But since the technology was denied, a massive effort was mounted by ISRO to develop the cryogenics rocket here in India. And first was a substitute for the Russian rocket engine was made. And concurrently, the design of a larger cryogenic rocket has taken up. That is what is going in the GSLV Mark III. It's a 20-ton thrust engine, and it is a really world-class. Of course, the design is highly optimized and very efficient, and reliability also has point that we have one of the best in the world.
Right.
So, PSLV and the GSLV put together, that becomes the workhorse. Which is the leading parts, I cannot say, but perhaps the Mark III will emerge as going to be the most efficient system because it can carry almost 4 tons of spacecraft into low Earth orbit. So, you have seen recently, even for a US company, about 36 satellites were carried by the GSLV Mark III and deployed. So commercially, it is going to be a large success. The commercial users will look at lower cost, higher reliability, and on-demand availability. All these criteria, GSLV Mark III can definitely meet, and PSLV is already in the production mode. So these two rocket systems are going to give us a good lead in space transportation globally.
Indeed. Our best wishes, sir. I'll be taking final questions as we wrap up the show. Starting with you, Mr. Gupta. Obviously, Chandrayaan-3, big event, and all hopes and eyes are there. Talking on the holistic picture, sir, how does it contribute to the India's overall, if we talk about space exploration goals and ambitions? Your thoughts on that, sir?
See, the space ambitions of mankind as such, because the space is the last frontier, unlimited frontiers. And for that you need great capabilities, and India does not want to lag behind anybody else.
True.
So we started a bit late, but we are catching up fast. And I hope that very soon we will be having capabilities in every field at par with any other countries in the world. We are today the world's fifth largest economy. In terms of technology, we are among the top three, four, or five nations. So space-wise, if you want me to name a few, we already have this moon mission. We have another moon mission which is not yet fully planned, but it is on the cards, the Chandrayaan-4. Not officially designated as Chandrayaan-4, where Japan will be collaborating with Japan, carrying the payload developed by Japan. Then we have already gone to the Mars, and maybe after this success, soon there may be another plan to go to Mars once again. The resources in the space are unlimited. And for that, now if we're talking of the moon itself, if we have to harness the resources available on moon, then it's a long way to go. Of course, this Chandrayaan-3, we are only taking the lander and carrying out experiments and developing, generating data and more information about the certain particular location. But if we have to carry back something, the next stage would be to bring back the Earth, moon Earth, back to the Earth and analyze here. Then perhaps another step will be to taking mankind to moon. So it's a just I would say what we achieve out of tomorrow's launch. It is a giant step, but at the same time, it is just a beginning, and it's a good beginning. So it's a long way to go, and the ambitions, I would say they are as high as the sky.
Indeed, sir, indeed. Dr. Nair, your thoughts on obviously Chandrayaan-3, but yes, just a beginning, more to come.
Well, certainly Chandrayaan-3 is going to demonstrate the technical capability and prove that India is second to none as far as its technologies are concerned. As we have described in the earlier discussions, the ISRO has been steadily progressing in this field, and it has set the goal of achieving self-reliance in space transportation, building huge satellite systems, and using the satellite technology for societal application like communication or disaster warning, earth observation, and so on. So that way, India has emerged as a space power. And the next target of achieving the human presence in space is already on the cards. Certainly in the days to come, when the space transportation is very much needed for including space tourism, India will be able to play a very major role. The technologies which are developed in the country are very efficient and cost effective. So that way, it is not only that we can meet the requirements of the country, but also take on the global players in this field. Only thing which I have a slight disappointment is the industries in the country have not really come up to the expectation of the organization, so they can take on the advantage or the mileage which is gained by ISRO and further capture the global market in a big way.
Indeed, Dr. Nair, efforts are on. I am sure the little knowledge about this aspect that I have, and with the entry of private players, also startups, plus government's aid, plus R&D, which is going on right at the university to higher educational institutions level. All this augurs well for India's space exploration measures. But nonetheless, thank you so much, gentlemen, for taking time out, sharing your views. Dr. Nair, Mr. Ravi Gupta, with your inputs, your views, not just me, but the viewers also, leave this place much informed, well informed, ahead of the much awaited, much anticipated, and our best wishes are there for the launch of Chandrayaan-3. To you and to your team, thank you so much for putting in so much effort and taking time out. So, obviously, two names from the Indian space exploration sector, Dr. G. Madhavan Nair, former chief of ISRO, and Ravi Gupta, former ISRO scientist, a very noted name and face when it comes to information and aspects related to exploration of outer space. Nonetheless, News 9 Live would be bringing you special broadcast of the launch of Chandrayaan-3 starting 2 p.m. tomorrow. Also at 11 a.m. on Friday, there will be a special show on the run-up, the countdown to the launch of Chandrayaan-3. Don't miss that. Thanks for watching.
ChatGPT. It can generate codes and human-like responses through text, write stories, and do a lot more.
I work in a newsroom with anchors, researchers and scriptwriters, graphic artists, producers, video editors, camera crew. But does a newsroom really need them